So I want to introduce and or formally. What I've done to do this is I've written a function truth p and q, which generates the truth table for p and q. It's actually an example of a nested loop. Then I have a second function, truth p or q, which generates a truth table for p or q. And finally, I have a main which prints both truth tables out and does some examples. Going back to what P and Q are, P and Q are logical propositions which are either true or false. And so if you have a truth table for P and Q, um, let me uh, let me run main, which among other things prints the two truth tables out. This statement here in main will generate the truth table for P and Q, and this statement generates the truth table for P or Q. The print /n/n between them does double line skip. So here we go. Alright, so here is the truth table for P and Q. And I'm going to let you look through the formatting in here to figure it out. Basically, it has column headings, the value of P, the value of Q, and the value of P and Q. And if you look at these two logical propositions P and Q, if they are ANDed together, the only time P and Q is true is if P and Q are both true. In all other cases, ANDing two logical propositions together is false. P or Q, it's kind of the reverse, but it's a weird kind of reverse. The only time, if you OR things, two logical propositions together, the only time they produce false is if they are both false. And so if you look at the truth table for P and Q, there's only one line that's true. If you look at the truth table for P or Q, there's only one line that's false. The line that's true in P and Q is the line where P and Q are both true. The line that's false in P or Q is the line where P and Q are both false. So as examples of that, I've written a function isDiv by n comma d, which returns true if d divides n, and otherwise it returns false. So we've seen this function before. n%d equals 0 is a boolean. It's going to return true or false. So all I have to do is return that, and it will tell me whether d divides n or not. So let's take the logical proposition r equals isDiv by 4 comma 2. R is in fact true because 2 divides 4. Let's take the logical proposition s equals isDiv by 4 comma 3. This is false because 3 does not divide 4. And let's consider the two additional propositions r and s, which I'm going to call t, and u equals r or s. And so before even looking at the run results here, r is true, s is false, and so from the truth table for and, if you and something that's true and something that's false, you should get something that's false. On the other hand, if you OR something that's true and something that's false, you should get true. And in fact, that's what you see in the printout here. Here is r, here is s, here is r and s. So ANDed together, true ANDed together with false gives false. Here's r, here's s, here is r or s. So if you OR something that's true with something that's false, you get something that's true. And again, I'm going to let you look at the format statements to digest that.